Hello everyone, welcome back to Husky Math. In this video, we are going to begin one of the most important chapters in mathematics, that is vectors. So let's start with the basic concepts of vectors and build our understanding step by step. So a vector is anything which has both magnitude and direction. For example, a velocity is a vector because it has magnitude and we have to specifically say its direction also. A vector is represented by a straight line where it has two ends. The starting end is called the initial point and the final point is called terminal point. This is initial point and this is terminal point. So the length of this arrow is the magnitude and this arrow is pointing at a specific direction, so that gives the direction of this vector. And it can be represented by any letter and on top of it we have to make an arrow sign. Or if this initial point is, let us say, A and this terminal point be B, then we can also write this vector as AB vector. So let's see different types of vectors. Number one, equal vectors. Suppose there are two vectors, let us say a vector A and a vector B. If they have same magnitude and same direction, then that type of vectors are called equal vectors. And we write that vector A is equal to vector B. Number two, negative of a vector. Suppose there's a vector A and if there's another vector which has same magnitude but opposite in direction with vector A, then this vector is called the negative of a vector A, and we can write this vector as minus vector A. The minus sign represents that it has opposite direction. Number three, zero vector or null vector. Any vector whose magnitude is 0 is called a null vector or zero vector. So if there is a vector A and if its magnitude, so we denote its magnitude with this bar sign here. So if the magnitude of any vector is 0, then this vector is called a null vector. Number 4, co-initial vectors. Any two vectors or more than two vectors which has the same initial point, then those vectors are called co-initial vectors. For example, suppose there are vector A, vector B and vector C. These all three vectors has the same initial point. So that's why these vector A, B and C are called co-initial vectors. Number 5, collinear vectors. Any two vectors which lie on the same line, then those two vectors or three vectors are called collinear vectors. For example, suppose there are two vectors, let us say vector A and vector B. And since they lie on the same line, that's why this vector A and B are called collinear vectors. And one thing is to note that they have the same direction also. And here we have to note that if two vectors are collinear, then we can represent one vector equals to the scalar multiple of another vector, where lambda is any scalar. So this thing we have to note. It is very important that if two vectors are collinear, then one vector can be represented the scalar multiple of another vector. Number 6, coplanar vectors. If some vectors which lie on the same plane, then those vectors are called coplanar vectors. This we will be learning more in the three-dimensional geometry. But for now, you just remember that two or three or more vectors, if they are lying on the same plane, then those vectors are called coplanar vectors. Number 7, unit vector, one of the most important thing which we have to know. Any vector whose magnitude is 1 is called a unit vector. Suppose there's a vector A, and if the magnitude of this vector A is equal to 1, then this vector A is called a unit vector. In general, a unit vector is denoted by A cap, not with the arrow sign, but with a cap sign. So if you see any vector and on top of it, if there's a cap, then we have to know that vector is a unit vector. And suppose there's any vector r which is not a unit vector. Okay, so this is a random vector which is not a unit vector, but in the direction of this vector r we can find a unit vector. And the formula for finding the unit vector in the direction of r is given as the vector r divided by the magnitude of r. So this also we have to remember. Let us consider our three-dimensional space. So a unit vector in the direction of x-axis is generally denoted by I cap, and the unit vector along y-axis is generally denoted by j cap, and similarly in the z-axis it is denoted by k cap. Remember that this I cap, j cap and k cap are the unit vectors along the positive direction of x-axis, y-axis and z-axis respectively. Components of a vector. Any vector r can be written as ai cap plus bj cap plus ck cap. This means that this vector has magnitude a in the direction of x-axis and magnitude b on the direction of y-axis, and similarly magnitude c in the direction of z-axis. So here this a, b and c are called the scalar components of this vector r, where ai cap, bj cap and ck cap are called vector components. Scalar multiplication of a vector. If we multiply by any scalar k with a vector a, then it is written as k into a vector, such that the magnitude of k into vector a will be equal to k times the magnitude of vector a. This we have to remember, and the direction of this k into a vector will be in the direction of a vector only. Number 10, position vector of a point. This is very important again. Let us consider our three-dimensional axis, and let P be any point on this space whose coordinates are x, y, z. And we know this is origin, and if I draw a vector from this origin to this particular point P, then the vector represented by this OP vector is called the position vector of this point P. So here the vector OP is called the position vector of point P, and it can be written as xi cap plus yj cap plus zk cap. This is very, very important. And one thing we have to remember, that if there is a vector AB, let us say, then this vector AB can be written as position vector of B minus position vector of point A. This also we have to remember. Number 11, direction ratios. Direction ratios are the scalar component of a vector. That means if a vector is there, let us say ai cap plus bj cap plus ck cap, then this scalar components, that is a, b and c, are called the direction ratios. In short, we write dr. Number 12, direction cosines. If in a three-dimensional space, if there is a point P whose coordinate is x, y and z, and if we draw a vector from the origin to the point P, then this OP vector is called the position vector of point P. But as you see here, this vector OP has made some angle with x-axis, let that be alpha, and this vector has made some angle with y also, and let that be angle beta, and similarly it has made some angle with z-axis also, and let that be gamma. So these angles, that is alpha, beta and gamma, are called the direction angles. And if we operate these three angles with cos function, that is cos alpha, cos beta and cos gamma, then these are called direction cosines. In short, we will write cos alpha as L, cos beta as M, and cos gamma as N. And for all these direction cosines, we have one formula, that is this L, that is cos alpha, can be written as x divided by square root of x square plus y square plus z square. M equals to y over, and n equals to z over square root of x square plus y square plus z square. So this we have to remember. And if we square all these direction cosines and add together, then the value will be equal to 1. So these were the sum theories we have to remember in vectors.